The stars, mainly composed of hydrogen and helium, with traces of heavier elements. How did we determine the composition of something so far away? We used the light that they emit and analyzed their unique emission spectrum. But what is an emission spectrum? To understand, we first need to understand light. Light is an electromagnetic wave. These waves are created as a result of vibrations between an electric field and a magnetic field. Light can therefore be represented as a function of energy. Light consisting of one color, called monochromatic light, is a sinusoidal wave with a specific wavelength. Since the function repeats itself, it is called periodic. Polychromatic light is a mix of many different colors. Since it is composed of many different sinusoidal functions, it can be either periodic or aperiodic. We can use this property of light to measure the energy released and absorbed by atoms. If we supply enough energy to an atom, it will make the electrons jump to a higher energy level. When the electrons jump back to their original place, they emit the extra energy in the form of light, called a photon. Because the electrons in an atom have specific energy levels, there is a specific distance the electrons jump, so the energy they emit has a specific wavelength, unique to the distance they jumped. This gives us a unique way to characterize each element. First, let's look at the continuous spectrum. This is a representation of all visible light. Each wavelength is interpreted by our eyes as a different color. When the electrons jump from a higher level to a lower level, they emit only a few wavelengths. This gives us the emission spectrum. When we invert the emission spectrum, we get the absorption spectrum. Each black line corresponds to a wavelength that was absorbed. So how do we measure the emission spectrum? We measure the intensity of the light released by the excited atoms. This gives us a continuous function. We can identify the peaks of the bottom graph. These are the specific wavelengths emitted by the atom. By using only the peaks, we get the discrete emission spectrum of an element. If we identify the drops in the top graph, then we get the wavelengths that are absorbed by the atom. You can see that the specific wavelengths are the same for both graphs. This scientific discovery allowed us to identify the elemental composition of objects too far for us to touch, the stars. By comparing the absorption lines of the sun with the emission spectra of known gases, the chemical composition of stars can be determined. This is a key characteristic used to classify stars.